Assalamualaikum to our lovely Dr. Faraz Suraya.
Today, we would like to present to you our group assignment. The topic that we choose is logical reasoning in everyday decision making. Here is our team members. Firstly, we have Nurul Nabiha. Next, we have Nurul Nisa Farzana, Nur Anissa Alia, and lastly, we have Fateh Nabila. Here is the topic that we would like to present. First, we're going to explain the introductions of the topic. Secondly, we're going to state a problem statement 1 and 2. Next, we're going to solve a solutions of the problem statement. Lastly, we're going to sum up all of the topic. So, let's begin with our introductions. Logic is an important component in life. It helps us to make decisions in our everyday life. It is because in real life we always choose whether it is good decision to be made or not. Because of this, logical reasoning in everyday decision making helps us on choosing the best options based on fact and reasoning. In this project, we will be exploring on how logical reasoning works, where we learn in discrete mathematics that can be used in real life decision making. By analyzing logical statements, identifying patterns, we aim to demonstrate on how discrete mathematics serve as a tool for solving complex problems and improving decision-making processes. Our objective is to show that a logical reasoning is to compare the options carefully to pick the most rational one. Next, to show that we should give a reason clearly when making a choice.
Let's move on to our first problem statement. So the statement is, Sophia wants to eat. If Sophia eats, then she is healthy. Sophia will eat rice or she will eat junk food. If she eats junk food, then she will be not healthy. Therefore, Sophia will eat rice or she will get sick. To solve this question, we need to follow these two steps, which is show that the argument is valid by using rules of inference. Second, use a truth table to test the validity of the argument.
Hello everyone, today I will explain how we solve this logical argument using the rules of inference. Let's break it down step by step. First, we have 5 statements. A means Sophia wants to eat, B means Sophia is healthy, C means Sophia will eat rice, D means Sophia will eat junk food, and E means Sophia will get sick. We are given 4 premises and need to conclude that Sophia will eat rice or she will get sick. Step 1. From premise 1, we know that Sophia wants to eat A. From premise 2, if Sophia wants to eat A and she is healthy B, then A implies B. Premise 3 says that Sophia will either eat rice, C, or junk food, D, which is written as C or D. Premise 4 tells us that if Sophia eats junk food, D, she will not be healthy, not B. Using modus ponens on steps 1 and 2, we confirm that B, Sophia is healthy. Then, using modus tollens on steps 4 and 5, we know that not D, meaning Sophia will not eat junk food. Using disjunctive syllogism on step 3 and step 6, we can conclude that Sophia will eat rice. C. Finally, using the addition rule, we write C or E, which means Sophia will eat rice or she will get sick. So, the conclusion matches the argument and it is valid. Sophia will either eat rice or get sick. This slide is about checking the logic of the conclusion using a truth table. The truth table helps us test if the argument is always true. In this table, we list all possible true values for the variables A, B, C, D, and E. For variable A, we will use 16 true. For variable B, we will use 8 true and 8 false. For variable C, we will use 4 true, 4 false, 4 true, and 4 false. For variable D, we will use 2 true, 2 false, and E, we will use 1 true and 1 false. First, we calculate the truth for each column step by step. First, we do the A implies B, then we do the not B, then we do the C or D, then we do the D implies not B, then we do the C
or E. Then we do the process where we need to check whether A and A implies B is true. And we do the A and A implies B and C or D. Then we do A and A implies B and C or D, and D implies not B. Then we compare all of them with the conclusion, which is C or E, to check if it's valid for the conclusion. As you can see, the last column has only true D values. This means the argument is valid and always true. So the truth table proves that the argument is a tautology.
Secondly, problem statement 2, question B. Argument statement for problem statement 2 is, if I sleep then I will feel energetic. If I feel energetic, then I am not sleepy. I am sleepy. There is two solutions for question B. Step 1, we must find the conclusion for the argument using rules of inference. Step 2, we must show that the statement is tautology using truth table. For solution step 1, which is by using rules of inference, we must find the variables p, q, and r and the premise 1, 2, and 3. For variable p, I sleep. Variable q, I feel energetic. Variable r, I am sleepy. As for premise 1, p implies q. Premise 2, q implies not r. Premise 3, r. Then do the step and the reason for each step like the tables in this slide. For step 1, 2, and 3, we just put the premise 1, 2, and 3. While for step 3, 4, and 5, we need to start calculate to search the step and the reason. For step 4, we are using hypothetical syllogism for step 1 and 2, where the statement when to P implies not R. For step 5, we are using modus tollens for step 3 and 4, which the statement when to not P. And lastly, the conclusion, not P, where the statement say I am not sleep. As for solution step 2, which is use truth table to find the statement is tautology or not, first we need to put 4 true and 4 false for variable P, 2 true and true false alternately for variable Q, and 1 true 1 false alternately for variable R. Then use negation for variable not P from variable P. Same with not R, use variable R. Then P implies Q, which is all true. Except true implies false, it will be false. Same with Q implies not R. Then do P implies Q, conjunction Q implies not R. After that, P implies Q, conjunction Q implies not R, conjunction R. Lastly, P implies Q, conjunction Q implies not R, conjunction R implies not P. So the result is the last column contains only this. Therefore, P implies Q, conjunction Q implies not R, conjunction R logically implies not P. So the conclusion is this truth table is tautology.
In conclusion, after we use some techniques of the fundamentals of logic, which are rules of inference, and truth table to the statement, we got the conclusion for our statement, which is A power of A implies B power of C, or D power of D implies not B implies C or E is tautology. From this, we can conclude that our argument is valid. Based on the situation, Sophia is hungry and has two options, either to eat rice or junk food. If eating rice will keep her healthy, then eating junk food makes her unhealthy. Therefore, Sophia must eat rice so she will stay healthy, or else she will get sick. For our second statement is P implies Q power of Q implies not R power of R. The conclusion is tautology. From this, we can conclude that our argument is valid. Based on the situation, if I sleep, then I will feel energetic. If I feel energetic, then I am not sleepy. In conclusion, I am sleepy. Therefore, not sleeping makes her sleepy.
That's all from us. Thanks for watching.